This is the Math 159 Gould Chapter 5 Section 2 video on theoretical probabilities. It will be in several parts. So I may remind you that last time we talked about what is randomness, and we talked about how probability is used to measure how often random events occur, and that theoretical probability has to do with what would happen if you were to repeat something over and over an infinite number of times. What percentage of times would the event that you're looking at happen, as opposed to empirical probabilities, which you get from data. So we're going to discuss theoretical probabilities. So there are some rules to probability that you need to know about. First rule: probabilities are written as decimals. So why do I bring this up? Well, normally we talk about people will generally talk about a 50% chance of something happen. That is a percentage. We will not use 50%. We will write it as 0.50. Likewise, we will not say 33% chance of happening. We will say 0.33. If you aren't familiar, it's easy to go between percentages and decimals. If you have a percentage, notice it's 50.0, so there's a decimal right here. If you move the decimal place over twice, you get it in front of the 5, which is why you get 0.50. Same for this. Ends up right there in front of the 3. Okay, cool. So probabilities are written as decimals, but more importantly, and are between 0 and 1. 0 being 0%, 1 being 100%, because people are generally more used to talking in terms of percentages. So when we talk about a probability, we talk about the probability of an event A. We always call whatever's happening an event, and it's generally denoted by an uppercase letter. So uppercase A means something. We'll to tell you what it is for each time. The P means the probability. So the probability of event A is between 0 and 1. 0% probability of something happening means that it literally never happens. 100% probability of something happening means that it always happens. Okay. So first rule. Let's have our second rule. Second rule of probability. So probability of A means I should have written this, probability that A occurs. But what you need to know for this is, there we go. What is the probability that A doesn't occur? Okay. That is written as 1 minus P of A. So the probability of A is the chance that A happens. 1 minus P of A is the chance that it doesn't happen. So let's talk about why this makes sense. Let's say that event A is that you win a prize. So what is the probability that you win a prize? Let's just say that it's, 36%. So if the chance that you win a prize is 36%, what's the chance that you don't win a prize? Well, assuming that you either win or you don't win, if you win 36% of the time, it makes sense that you don't win a prize the rest of the time. That is 100% minus 36%, which is 64%. And you would get that by doing 1 minus the probability of A, which is 1 minus 0.36, which would give you 0.64, which is that number. Okay, the something not occurring, we call that the complement of A. So there's A, the event, and then there's the complement of A, that's A not happening. Okay. And let's talk about our third rule. The way that you calculate the probability of A is with a formula. And before I explain the formula, I need to define a term. The term that we're going to define is the sample space. So the sample space is all possible outcomes when discussing your event. Okay, so for instance, if we're talking about like, I don't know, winning a prize or going, what happens after you play a carnival game? You either win a prize or you don't win a prize. The sample space would be those two things. Okay. So the way you calculate, so A, the event A is one of the outcomes in the sample space. Okay. So the way you calculate the chance of A happening is you count the number of ways that A can happen. So number of outcomes in A. So A is something, maybe there's a variety of things that you're discussing in A. So for instance, like you could be win a prize or win cash or get to retry it or something like that. And then what do you divide by? The number of all outcomes. Okay. So let me write this a little more clearly. Number of outcomes in A divided by number of all outcomes, just in case you weren't able to read it. Okay, now caveat, this only works if all events are equally likely, which luckily enough actually occurs most of the time in real life. Okay, so let me give you an example of how this works. Let's say that there's a bowl filled with colored beans. The beans are colored as follows. There are 5 red, 3 green, and 2 white. It makes sense to assume that if you blindfold yourself and mix the beans and pull out one, that all of the beans are equally likely. Why am I bringing this up? Because I said that my probability formula only works if all events are equally likely. There's no real reason to assume that red beans are like more likely or more drawn to your hand than white beans or something like that. Although you'd be surprised, there are a variety of experiments that show like even if you think things are equally likely, usually there's like slight differences of things happening. So it's a decent assumption, but isn't always true. So let's do some calculations. Like, what is the probability that you draw a red bean? Oh, whoa. Ah. Sorry about that. What happened? I don't know. What is the probability that you draw a green bean? Okay, cool. So, let's do A first. So, we're talking about drawing beans. How many beans are there to draw? Well, there's 5 red, 3 green, 2 whites. So the sample space is those 5 reds, 3 greens, and 2 whites. That's 10 different beans, 10 different outcomes. So the sample space is size 10. Now, if A is drawing a red bean, well, how many different ways can you draw a red bean? 5. 5 out of 10 is 1/2. If you convert that to a decimal, it's 0.5. So in other words, a 50% probability of drawing a red bean. So pretty straightforward. Same thing. Well, assuming that we put all the beans back and start over, and there's 10 beans you can pull. How many different ways can you pull a green bean? 3 different ways. And that's 0.30. 30% chance of drawing a green bean. Boom! Pretty easy to do. But, like most things in life, nothing always stays really always super easy. So we're going to do a slightly more difficult example. And this will involve suppose you have 2 6-sided die. So what do I mean by that? You know, the die that go One side has one dot means 1, another side has 6 dots means 6, and so on. So let's say you have 2 of them, and you're interested in the sum of the pips. The pips are the little things that show the numbers. So if you see the die has the side up that has the 3 little dots, the little dots are called pips. So you're just saying that we add the numbers together. So if you have one die that says 3 and another die that says 2, 3 and 2 is 5. That was the number we're curious in here. This is, interestingly enough, if you've ever played craps at a casino or with your family, you're interested in the sum of the die as opposed to something else, or the 2 numbers separately. So what we're going to do is compute the probability of... so what are your samples? I guess let's talk about the sample space here. So what's the sample space? So because you have 2 die that are numbered 1 through 6, the lowest you can get is 2, right? Because you can get a 1 and a 1. And the highest that you can get is 12, because you can get a 6 and a 6. And then you can get every other single number in between. Okay, so let's compute the probability of several of these. Okay, so the sample space is all those different numbers. And so now we got to figure out, so let's do, I guess, we're going to do, what's the probability of getting a 5? Yeah, we'll do the probability of getting a 5. Okay, so we're going to use some notation. So because there's 2 die, we're going to talk about die 1 and die 2. So if I write 3, 2, that means I had a 3 on die 1 and a 2 on die 2. That is a 5. Now that's not the only way to get a 5. I could have a 2 on die 1 and a 3 on die 2. That's a 5. What's some other ways I can do this? I can do a 4 and a 1. A 4 on die 1 and a 1 on die 2. That is also a 5. So notice, even though those are all different rolls, they mean the same thing, right? Because you add the numbers together. And this highlights that you have to pay attention to which number is which, right? Because you can have a 3 on the first one and still have a 5, and you can have a 4 on the first one and still have a 5. Okay, so the way we usually do this is I'm going to mark, well, what is die 1? So die 1 is going to be these numbers over here. 1, 2, 3, 4, 5, 6, because I can roll a 1, 2, 3, 4, 5, 6 for die 1. Die 2 will be these numbers up here. I can roll a 1, a 2, a 3, a 4, a 5, and a 6. Now I'm not interested in those numbers per se, I'm interested in the sum. So a 1 and a 1 gives me a 2. Okay, so that would be a 1, 1. The next number below it would be 3, and that would be a 2, 1. I could also have a 3 right here, but that number is 1, 2, right? Remember we talked about this? They're the same, they have the same sum, but they're different rolls. One second. Okay, so you can quickly just fill all of these in. So you can go 2, 3, 4, 5, 6, 7. Why is this a 7? Because you have a 6 and a 1. So the 3, 4, 5, 6, 7, 8. Why is this an 8? Because you have a 6 and a 2. 4. Why? Because it's a 1 and a 3. 5, 6, 7, 8, 9. Why? Because it's 6 and 3. Notice it's easy to fill it out. You just keep on going, adding 1 as you go below. So next one up here is 5 because it's a 1 and a 4. So 5, 6, 7, 8, 9, 10. Why is it a 10? Because you have a 6 and a 4. 1 and a 5 is 6, 7, 8, 9, 10. 6 and 5 is 11. 1 and 6 is 7, 8, 9, 10, 11, 12. So notice, right, your lowest is 2, your highest is 12. You get that when you roll a 1 and a 1 and a 6 and a 6. Okay, so, well, let's calculate our probability of 5. So what are all the different possible outcomes? So notice this is a all the outcomes are in blue, and it's in a grid of 6 by 6. There are 36 different possible outcomes. How many of those have the number 5? Well, you can see that all of the 5s are situated right here. You can do the rolls of 4 1, 3 2, 2 3, and 1 4. There are 4 different ways to get a 5, so 4 out of 36. Thank you for watching the video. Sorry, someone's calling me. Bye.